The manufacturing facility of the future will have two employees. There'll be a man and his dog. And the man is there to feed the dog, and the dog is there to keep the man from touching the equipment. And it's funny, and it's a joke, but his point was that's not true, because the lights out kind of facility has proven to be not a good way to run things. The revenues and the profits from illegal drugs is smaller than the revenue and profits of cyber attack. And the general form of cyber attack is loss of use. They're going to stop you from doing your operations, or worse yet, make it malicious. If I decide, hey, I'm going to force my customers who buy my equipment to use my protocols and my networks, etc., to the exclusion of everybody else, what they're really doing is holding their customer for ransom, and it's not cool. It's not okay.
Hello, everybody, and welcome back to the Practitioners Unplugged podcast, where we dive into real-world stories and strategies of manufacturing digital transformation. Join us as we hear from thought leaders and innovators who are driving change and shaping the future of Industry 4.0. Whether you're a seasoned professional or just curious about the future of manufacturing, this podcast is for you. Today on episode 14, we're excited to have Craig Henry with us. Craig currently sits as the Global Account Director for Amazon at Merle Electronic. He holds a bachelor's degree in mechanical engineering with a certificate from Harvard University in cybersecurity. Craig has over 30 years of experience in advanced manufacturing and intralogistics systems. His tenure includes advancing global projects at Amazon, national roles at Siemens, RT Engineering, and Danaher. He's also the author of a new book called Super Connected: The Future of Industrial Nervous System. He brings a practical view of the emerging Industry 5.0 perspective and looks to debunk hype around AI. Craig, welcome to the podcast. Is there anything I missed from your introduction or you want to elaborate on?
So, yeah, that was great. I feel better about myself now that you've read that great history of what I've done. It sounds very impressive, at least to me. So, yeah, you're good. We're right on here. Let's jump into it.
Awesome. All right. Well, I want to start with kind of like the title of your book, right?
Yeah.
And can you really just define what the industrial digital nervous system is? It's a concept and a title, like without reading your book, because it's not released yet as of today. I'm just trying to figure out, like, what's the substance?
What is it about?
Yeah.
Why do it? It took a while for me to come up with the title because I knew what I wanted to talk about, and Super Connected is exactly right. We have a world that's expanding and changing very quickly in many ways with respect to intelligent systems, and in operations, the brain of operations is going through a massive expansion through AI, but it assumes something that's missing. It's assuming a connection to the real world. And as this brain expands and it can think and give responses and identify objects through cameras, what's missing is this forgotten middle. It's the layer of connectivity. And as I've talked with Amazon and others in the field, I'm seeing that when you get the connectivity right, it opens up all of the promises of Industry 4.0 and Industry 5.0 and the digital twin. But without it, we are crippled. We're almost as if we're operating a brain that is suspended in space and isn't connected to a body. So I made this analogy in the book to the human body, that our nervous system is the way that we take the brain and connect to our bodies, and then therefore connect to the outside world. So that's the core of it, but I get into a number of different, sub topics within the book that basically turn out, it's a relatively quick read, but it gets right down to, let's use the tools we have today to make the best of operations and not get mired in some of the hype, I think, that's going on, particularly with large language models, and really get down to what can affect our bottom lines and our competitive advantage. So that was not succinct, but there it is.
No, it was a great introduction, especially the tie into the nervous system, the human nervous system, and its digital equivalent. If I recall, I think Bill Gates used the digital
Mhm.
nervous system, the business as a digital nervous system, back in 2000. I
Yeah.
think he had his book was, I think, business at, something at the speed of business.
Yes. Yeah.
Anyway, but great analogy, metaphor for even for architectures, because if you look at the human body, we have over 1 billion neurons. And if all those billion neurons went directly to the brain would shut down. You actually have a very, a great, the spine does a very fascinating job of which signals are sent to the brain, what is processed locally. There is a distributed architecture there. When we go to sleep, we don't stop breathing. It turns out there's actually something like 6 or 7 different sub nervous systems in there. It's just completely
Oh, it is.
fascinating.
It really
But
is.
the whole thing, when you think, the I love the super connected idea because it's all coming together, but there is some intelligent architecture underneath that's worth unpacking.
Yes, yes, and I think that if we look at it in some simplistic terms, it can be revolutionary the way we consider the way that operations are going, particularly in manufacturing or in fulfillment centers, logistics. We have to have a connection to the outside world. But what's changing today is the devices themselves are becoming much more capable and communicative and complex to the point where you have AI residing on field devices. There's AI in cameras that you can get from various manufacturers. There are high-end networks. There's EtherCAT and Ethernet IP and Profinet already native on field devices. So we end up with and this is a key part of what I put forward in the book, is that there is a field level that has become a kind of swarm intelligence. And then we have the cloud and the edge, above, which is advancing very quickly with AI and machine learning and looking for patterns. But in the middle, what we have a big breakdown. And that's the place where I'm promoting a kind of OPC, UA, open architecture, where we get away from signals and get to communication networks as quickly as possible, so that we can essentially see that field level. Because now I think we have a 30-year-old view of control systems for the most part, or an installed base that's that old, and it creates a kind of paralysis. We cannot feel what's going on at the extremities of our organizations because there's this black box effect. And so being super connected is what I'm saying, is move to that, and you're going to open up a world that our digital tools will just go crazy with. We'll absolutely be able to bring such insight to your operations that you didn't have before.
I think one of the points that you're talking about on this super connected is that it extends with outside of like the four walls of traditional manufacturing.
It
Right?
must.
So
It absolutely must.
when we talk about sensors as they exist today, like from a PLC perspective, it's basic logic. I see this, do this, right? But now you're talking about opening protocols and this super connected, where if I use your digital nervous system example, it's kind of like the same way that we approach things as a human, right? I have a vision system, I see something, but if I don't know anything and I'm not learning anything, like I'll touch fire. And now visually I saw that that's fire, but I didn't know it was hot until I touched it, right? So that's incorporating vision now into this sensation. Now visually, when I see that same anomaly before, I'm not going to touch it because I know what that downstream effect of that. So that's kind of like breaking away from the linear side. But then how does that feed back into this customer experience concept that we talked about before? Because traditionally we think customer experience is not connected into the four walls, but how does the super connected ecosystem come back to enhancing that?
Yeah, when you're talking about a customer, the end user of technology, I think folks like Amazon and Walmart and others have made their processes very transparent to us as customers. in that we can order something and then we see that it has shipped and then we can track its shipping, etc. And I use in the book the glass, well, the glass factory, or in this case, the glass kitchen of Domino's restaurants with their technology spend that they did years ago to show when you order pizza from them, you're going through the stages through their tools, and you can watch everything happen. And in so doing, and I think it was also coupled with some improvements in quality, but they captured 42% of the pizza delivery marketplace, and they had quite a rivalry with some of their competitors up to that point. But because they made everything digital such that it could be seen by the customer, that was seen as extremely valuable to customers. And I would propose now, and this even has been informed by customer conversations I've had this week, they want to know, what is your inventory? Can I buy this now? When can you ship it? Did it ship already? These are the conversations they want to know from manufacturers and fulfillment people, that transparency. And you cannot have that unless you have the data available, and not just all the data, but specific data that you can curate with very low latency. And that takes more than a signal. Those of us in the operations world and in automation particularly, we're used to dealing with signals. Let's say there's a sensor out there and it's indicating speed of something. Let's say it's speed of a conveyor and it's an analog signal. Well, if you ask the CEO of the company, what's the speed of that conveyor? What connectivity does he have to that? I mean, that may be a silly thing to ask, but if that system's down and there's key customers that are about to be lost, how do we see that sensor? And I would say that in most cases, in another state or even in another country, there's no way to drill down to that plant, get past its cybersecurity, get through the edge, get down to that particular cell, and then get to that control cabinet that's running on a PLC that was 99 to 1 written by someone outside your company, and say, tell me what that speed is. But no. But if we're not using an analog sensor and there's digital information coming into an open system, not a black box closed system in a PLC, for example, you've gone beyond that, and you can begin to put into place a means of seeing everything. And that's something that I think is essential today, is that we get to digital signals and get away from anything analog and anything that's invisible. So there's a lot there to unpack, but you guys, I think, would understand that from where you are in the operations world.
Yeah, it is. It is. When I think about, I think some of this has echoes of the same IT/OT, divide, disconnect,
Mm-hmm.
the thing that where we're trying to converge. And, in many ways, I feel like the OT world already does what the IT world has yet to get to, which is real-time
Mm-hmm.
operations, always
Mm-hmm.
on. Whereas I think IT tends to be, more transaction driven, a system waiting until, an order comes in or whatever. Whereas the world of OT is like always on all the time, right? But we didn't necessarily see it.
Correct.
And there is an opportunity to expose this world,
Mm-hmm.
but the downside is that it's a bit of the Wild West.
Isn't it funny that it is, in the sense that we've been using IT for 60 years in business, and we've also been running factories, and the PLC itself was developed in the late 60s, and here we are so many decades later, and we're still talking about the IT/OT convergence, which to some, me included, would mean, oh, we've got to deal with IT now. So let's see if our systems can connect. Well, they kind of can, but there's security issues, and well, that doesn't meet our protocol, and they can't control that because it's not a domain anymore, and it's a very difficult thing to really get IT/OT convergence. And if you take that, in my opinion, you take that to the next level, we we need IT OT convergence already today to be in place to go to the next level, and we don't even have that yet. And my concern is that we're going to solidify ourselves in this gap that still exists between IT and OT, and we're going to bring in all these tools which are not human, okay? And they are going to use whatever information they can get, and it will be incomplete, and they're going to make bad decisions. The AI will make bad decisions because it doesn't have the data. And so, what do? And my point is, get the data, make the connection, and then everything will work. And it's more than IT OT convergence.
So let's unpack this one a little.
This is big.
Yeah, let's unpack this one a little more, Craig, because I think in the industry today, we're either led by software or ambition first, meaning that we need AI, we need the software, and we get sold on that because you can see that, right? If somebody's presenting software to me, I can see any data in the world that I want. I can see any widget or dashboard or trend, but what I always see is that digital nervous system is an afterthought, right? So we're led by software first, vision first, all this other stuff, but the realization of that vision or that what that software can deliver is overlooked because the architecture and the infrastructure required for that is often overlooked. So how are you seeing this impact the way that projects are going? So I want to kind of get your thoughts on two areas. So one, greenfield approach, and then two, brownfield, right?
Okay.
Hey, I missed the boat. I have a live operating system. How do I get connectivity? And what you're suggesting here is a lot of like open protocols, Modbus TCP, IP, intelligent sensors.
Sure.
That's a home run with Cat5 everywhere. So it's kind of disruptive. And so, like, what are your thoughts on enabling this both in brownfield, greenfield, given the infrastructure laying? Because if I look at, like, I spend a lot of time in steel plants, right?
Mm-hmm.
If I want to go put a sensor at the end of the line, I would have to get I'd have to probably put it in conduit. My lines are 3 football fields long. If my control cabinet's on the other side of the plant, I've got to run conduit from there, home run something all the way down to the end of the line. I could be going up 300 feet. I could be going over 1,000 and back down 300 feet again by the time I'm there. So a $200 sensor could cost me $20,000 to get installed or whatever, right? So just want to get your thought on this balance and when these considerations need to happen.
Well, there's a lot there in, you're taking an industry that's difficult. It's dangerous. It's dangerous and it's dirty, and the failure modes are big in steel production. I remember being in a steel plant earlier in my career, and the guy had given me a hard hat, etc., and I'd already ruined my shoes. But anyway, we're walking through, and he says, "If you hear something that sounds like the end of the world, don't look to me. There's the exit. You need to run." That's what he told me. I was at Birmingham Steel, I think, maybe U.S. Steel. But your point is, this is not easy to get this visibility, to get this nervous system in place. My point is, it's okay. So it's going to be hard, but we have to look at what are the failure modes and what are the things we want to improve to make sure we have, an uptime that continues to increase and a visibility to problems. And my point is, don't get that conduit put in place and put in a signal. You want to put in communication. You want a self-checking, deterministic, error-checking, and encoded signal that will go through that conduit, and that you may have to have repeaters along the way, in the form of switches and whatnot, so that you can get it back. Because I would venture to say having that data could mean you've saved $1 million problem down the line from happening. And the 20,000 would be, small compared to what could be, just operating blindly and hoping for the best. And that's the way a lot of plants operate. Depending on what you're manufacturing, what you're doing, it's after the fact. It's reactionary. Oops, something broke or something went down. What happened? I don't know. Let's go find out. And we do a postmortem. Wouldn't it be better to know that there was vibration that usually indicates that we're getting close to something dying, or there was heat, or there was excessive amperage being drawn in this particular area, and we would know through our condition monitoring that, hey, Next PM, let's check that out. And we've moved unplanned downtime to planned downtime. And I think I think everyone should take the same approach that Bezos did. And this was 20 years ago plus, when he said, every system that we have in my operation will have an open API and we will be able to see it. We're going to be able to expose data from every corner so that we can get after it. And there'll be no black boxes. There'll be no hidden things. And I think that as best as they have been able to, that Amazon's been able to do that, but they still have black boxes and hidden areas, and it's a struggle. It really is. The struggle is very real. But I would say yes, if there's a failure mode that could be painful and expensive, run the conduit. Get a smart sensor there and work through that nervous system to go from paralysis to now you can feel again, or for the first time. That's my premise. And I'd say money spent in this space, this what I call the forgotten middle, is the place where you will get the best return on your investment the fastest, because now you'll be able to see and feel what's going on in your organization. And AI is great for that. It's a pattern. It's watching for patterns, and you have to see what are the patterns. And if you can't see any data from it, you'll never be able to use AI and machine learning neural networks to do what you need to do.
I think that's a fair point, because I hear this often when we're going through upgrades, whether it's capital equipment, we're redoing lines, something like that, is this term of value engineering. And a lot of stuff gets pulled out, right? Data, oh, we're not using it, we're not doing it. Then all these problems precipitate. Customers are like, hey, how do we solve this? It's like, well, do you have this infrastructure? And no, that was value engineered out. And the cost to put it back down is often like 30, 40, 50% higher than it would have been if you just would have considered it from day one. So I think that's kind of one of your lessons that you're talking about from Amazon, is they took a let's just get data first approach, not knowing how or why that they're going to leverage, but saw the value in it on the front end before actually committing, waiting for a justification after the fact.
Yeah. And this is something that has to be top down. It's going to be expensive. And I think that all the data indicates that automation is a must. We have a huge labor crisis, which I want to touch on, but they know it's expensive, but I'm not certain. And one of the reasons I wrote the book is that I'm not certain it's clear where you should spend your upgrade dollar. And I would say that you'd be hard pressed to find something better than in getting visibility in the nervous system of your systems. That nervous system is where you're going to discover all kinds of inefficiencies. And my dad, who's a former IBMer and was a CTO for duty-free stores, he says, we don't know what we don't know. And that's dangerous. And if you can start feeling, and setting up that nervous system, you end up knowing things that you didn't know before, and you start making adjustments, and you can see 20, 30, 50% improvement in certain metrics just because you now can see and feel that organizational data. And it's not data for data's sake. It's just it's data that obviously will have value. But Bezos's point, his manifesto back, and I think it was 2002, is I don't know what we're going to do with this data, but I'm going to have the data. And I've heard engineers say that as well. We have to produce the data. It has to be available because we know that we're going to need it at some point.
Can you contrast between, when I think about factories versus warehouses and the technology that gets put in?
Like, how are they different?
More like the rate of technology adoption. I think that, if I have an old steel plant, maybe it's a little bit more difficult. There's a reluctance to invest because of economics, etc. In the world of warehousing and distribution, is that world progressing faster in being super connected? Is the Amazon factory, is that driving, all other uh,
Mm,
warehouses and
mm.
distribution centers to emulate that? What do you
Yes,
see?
I think with the worlds are somewhat different of manufacturing and with just fulfilling orders. On the other hand, they're also very similar. With manufacturing, you're adding value to stuff that you purchase, and you add value and integrate them together and sell them as something that has more value. With a fulfillment center, you are sorting through what could be millions of items. Manufacturing, for the most part, is material handling until you just do the value add part. So they are similar in that respect. Now, to answer your question about which ones are moving forward, I think that for the most part, warehousing and fulfillment is painfully manual in the world, and even in the U.S., in the Western world too, and that it may or may not be the right thing to put in a bunch of robots. Um, that I think it gets down to what your strategy is, and this is where the board of directors and the C-suite needs to earn their money. Is where do we get our competitive advantage? What can we offer, for example, like Domino's, to our customer that will take us from here to here? And if it's steel production, well, what is it? Is it availability? Is it custom orders quickly? Is it, I mean, that your strategy has to be first. I'm a big believer in strategize before you digitalize. Okay, get your strategy right. We're going to go from here to here because we know our business, and we know that if we do these things, blue sky it. If we can do these things, we're going to gain major market share and serve our customers better. What does that technology look like? Don't know. It depends on what you're trying to do. In fulfillment, we have a multi topic optimization. And if I'm going to choose profitability, we'll do these things. If I'm going to choose customer service, right product, right place, right quality, right time, right price, okay, that's another way to optimize. Or if I think, reduction in labor, if that's my goal, okay, well, that's going to be some different technologies. So you have to decide what your strategy is. What are we doing here to make our organization better? And there's no one size fits all for that. But what does fit all is your operation should not be reactive. It should not be clipboards. It should not be at the end of the day. Let's look at the screen. Oh, we had 56% overall equipment effectiveness today. What happened? We don't know. Let's talk to the managers. Let's talk to the supervisors. Let's see what machines are down. No. It needs to be real time while things are going. What happened? Do I need to bring in a third shift or whatever so we can make sure those numbers go up? So I'm not sure I'm answering your question directly. And you mentioned earlier about greenfield and brownfield
Well,
too, but I don't think there is a one size fits all. I don't think. I think it gets down to a courageousness of the management team of an organization saying not only that they want to do something and are willing to invest in it, but they know their business well enough to say, this is going to work. Damn the torpedoes, burn the bridges. We're going forward with this. Let's do it. And having that vision.
yeah. So sometimes, I love the word super connected. And as I try to paint this picture in my head, I'm visualizing this mesh network,
Mm-hmm.
right? And your first point is that, the more data you can get, don't be afraid. Like, don't be stingy. It's going to pay off
Mm-hmm.
at some point, right? Just invest in the things, invest in those nodes, the sensors to get the data, because what you want is higher fidelity twins, right? The more sensors, the better the fidelity of the signal and the descriptive ability to, they used to say, in the old days, we take the expert to the problem, but today you can take the
That's
problem to the
right.
expert wherever they are, right? So lesson number one in this mesh network is put in the sensors, invest in the
Mm-hmm.
infrastructure. Then if I look at this network, some nodes are going to need humans for various reasons. One is, it's just that I have age, it's less automated. The human is the sensor, right?
From the beginning of time, that was the way we worked.
Yeah. And then as processes become stable, I might be able to automate the human out of it, right? But yeah, what are your thoughts on, sort of this human in the loop versus
Yes,
when you
that's
automate?
a
And
huge
yeah.
topic, and I'm glad you mentioned it. I just posted this a few days ago. I've got this T-shirt, one of my many T-shirts. I need a closet for all of them now, and it has a barcode and it says human.
Oh,
It
it's a
just says
human.
human, and it. At one point, I was going to do this video, but it seemed kind of clownish and stupid. But I still may do it. Where I'm going to Target and I'm trying to scan myself. Anyway, so I'm wearing this thing and I'm going like this. And my point is not human in the loop, but human in command. You mentioned something in what you described, which may go by many of the listeners, and we think, oh, that's cool. You said, okay, it gets steady state, and then we can walk away and we can just let it run. There's a quote, and what's his name? I'm sure I should have his name like on the tip of my tongue, but he put a quote together that said years ago. He said that the manufacturing facility of the future will have two employees. It'll be a man and his dog, and the man is there to feed the dog, and the dog is there to keep the man from touching the equipment. And it's funny and it's a joke, but his point was that's not true because the lights out kind of facility has proven to be not a good way to run things. You got to have someone who has the experience, the judgment, the overarching ethics, etc., to be able to take the data and go, wait a second, here's something that hasn't happened before. Let me manage that. And the system should be able to push up to him. I'm seeing this. Here are three options. Please choose one and approve it. Let's go this way. And I think the human in command is the place where the future is going to be. This is Industry 5.0, which is not just, okay, a person over here and a machine over here, push the button and make it start. Okay, and now we're getting human in the loop. Okay, there's a person watching a screen. Okay, we have a SCADA, okay, but he's sort of in the loop, or she's there to start the machine, stop the machine, tell something is wrong. It's the human in command, where the human may have 20 stations that they're responsible for, and we're going to manage the exceptions as humans. I think that's the place where we're going to have the most success in the same way that with chess. You know, the best chess masters will perform the best if they have a computer to run simulations and to say, consider this. And then the master can say, I'm going to head this direction. I can, as a human, I know that I'm going to do this gamut and I'm going to approach this in this method. And between the two of them, they have the highest performance.
Yeah, no, I think you're onto something with the human in command label, because you can Google this. There's the 10 levels of automation that was defined many years ago. The lowest level is there's zero. It's all human, and then the highest level is everything is
Right.
automated. The decision making, the whole closed loop. But the point you're making is, regardless of where you are on that level, the human is always in command,
Yeah.
because there is a level above that. There is a decision maker. Even at the level below, maybe you've automated the human out of the system. There's always supervision, right?
Exactly. And I think that we're getting to a point where there's a skills fade happening right now. And it's always been in place. And the more I researched this and put this into the book, the worse it got. I mean, the truth got like, wow, I didn't realize it was this bad. And here are the problems. And I think this will speak to the need for human in the loop and the need for automation. So problem number one is the global labor crisis. We don't have enough people to do the work, or that are willing to do the work, that can do the work, et cetera. It's a huge crisis. I think in fulfillment and automation for fulfillment centers alone in the United States, we're 500,000 people short. Okay, so that's a problem. I think the number is about 6 million in the United States right now of open positions that haven't been filled and are waiting for someone. Couple that with the second problem, which is the competency crisis. We have about 87% of companies are saying the biggest gap we have right now to get to the next level in our advancement in this company is the skill sets with people we can bring in to help us do that. Now we have people and we have them doing things, but there is a skills gap, okay, and a competency issue there. What makes it much worse is in the next 5 years, 1 out of 3 jobs will be significantly different. So it's a moving target. What do we train people to do? And this idea of, okay, you get a degree way back when, and that's going to keep you in a good position for the rest of your career. No, you have to continually upskill, etc. So that makes it even worse. Now let's get into this thing I mentioned before, skills fade. If the automation seems to be working really well and I don't have to touch it, things will be fine until they're not, and then something catastrophic happens. And I think we take our hands off the wheel. Tesla had this issue. They were testing and doing automated, the autonomous driving vehicle. And there's a driver in the car. And they ran into a lady and killed her. Because the driver thought that the automation had everything under control. So, I think she was gone. Maybe she was just injured, but still hit somebody. So we get into this kind of skills fade when the automation becomes so much stronger, and it's going to continue to become stronger in a faster and faster rate. So with all that happening, we do need a strong and clear message for where humans really need to be in the loop and clarify that position and give them plenty to do. Don't worry, there'll be a lot to do, but give them the tools and the visibility to say, nope, I need something here, or no, I'm going to shut that line down, or I'm going to make sure the next PM happens and this line is going to be fixed. I'm moving to this, or maybe we route stuff differently so that those anomalies can be handled. And we can continue to automate, but there'll always be that place for the human. Because in the end, the old trolley test, which is trolleys going down the track, it's going to run into 5 people if you don't divert it. So if a human can divert it and it goes down this other track, it kills 1 person. And that trolley test is, do you intervene as a human, but still something bad happens? It's a dilemma. And my point is that the human must be the one, because in the end, not doing something and letting the automation cause bad things to happen is not acceptable. There's an accountability, and it's going to be human.
There's an interesting question that I've been kind of festering internally, like just listening to you talk on this. I think one of the things that we hear is everybody wants to go lights out. We want to get increased automation. But then if we're looking at the effects of like just using large language models on people right now, 80% of the people that use them can't recall the content of what they produced off of LLMs.
Yeah.
And if I go into that same paradigm now on the manufacturing floor where I have this human in command, and I also want to pivot it to your cybersecurity background, because this is that key point here where these systems can now become corrupted. So given the fact that we've been in this autonomous realm where I haven't really had to think or make reactions because the system has been reliable, if, let's say, nefarious actors take control of our systems, there is some corruption, and now I have a human that hasn't been able to think for themselves in a really long time on how to react to that. How do you manage that? Like, how do you say, I want resiliency, but I want you to do Overwatch, but you have no training where if that Overwatch needs to take in, where you have to now become in command, you lack the skill sets to be able to react. So how are we balancing that?
Yeah, that's going to be a tough one. My wife actually works at the clerk of court, and they use a software for recording deeds and mortgages and all kinds of things. And they got cyber attacked. This is about a year and a half ago, and the systems went down. Well, my wife knows how to do everything manually. And you'd be surprised how much resistance she got when she said, I can just go get the books and we can record and we can get this stuff done just like they did it before the computer was doing it. And then when it comes back online, we can feed it in, but we can still operate. And there was resistance to do that. And almost there was a point where people weren't even considering doing that. And so I think there comes a point of no return sometimes with automation where there's no way we could possibly do it manually. If you have robots doing things, you can't suddenly employ 1,000 people to do what all these robots were going to do. But we have to be able to have a plan A, plan B, plan C. And to your point, that a human is there, skilled and experienced enough to be able to drive that and to make those decisions, like an air traffic controller. Okay. That's a human being. Could we just automate all of that? Well, yeah, and it would be fine until it wasn't. And if it wasn't,
I guess that's the next
bad
paradigm that people are going to try to have to unpack is, how do we do this? What's the right level of training? What's the right level? Is this going to be hybrid? Is this going to be lights out? And then this what if scenario. It's an interesting paradigm because I've seen cyber attacks shut down places for months and months and months. And if you don't have that resiliency built in to be able to do some sort of hybrid manual disconnect from like AI into the future, like how are we going to operate? And I think that's an interesting question.
That's a great question. And that's a key thing I wanted to bring up too, in that cybersecurity, that's the new criminal. The revenues and the profits from illegal drugs is smaller than the revenue and profits of cyber attack. And the general form of cyber attack is loss of use. They're going to stop you from doing your operations, or worse yet, make it malicious. But it's usually a stop of use and a ransomware or whatever. But that's the place where we've got to be careful about exposure, and we have to be clear that it's going to happen. That's one of the things I learned about cybersecurity, is that you don't just hope for the best. You drill and you go through scenarios so that you are ready to save and secure your data and respond quickly when something like that were to happen. So if we rely on this system, however automated it may be, we have to have those secure systems in place. We have to have a plan when things go badly. We have to have our data in 3 places, et cetera. But also we have to be able to say, okay, when we have loss of use, how do we operate? And I saw a panel recently where it was a group of senior people, and they were saying this idea of securing your organization from cyber attacks is everyone's role. Because if things go down, everyone's processes stop. It's not just an IT thing. We have to make sure we have a plan there. But what do we do with the human? I think is what we were talking about. We have to deploy human beings to not just be there to push the buttons, but to own the process. Own the process. You have to own it and understand how it breaks and doesn't work and how it fails, so that you can make decisions about it. And then we use AI and all the sensors. And if you followed, what I'm reporting in the book, is you have that visibility to see and feel what's going on in the organization and be able to say, I think this is what we need to do. And I think this is what I'm seeing, as AI should be pushing up. I see this, and here are some options. Which one should I pursue? And that's not here yet. I think for the most part, that is a little ways off, where we have that kind of AI interaction on a larger scale, but it's coming quickly.
The human theme keeps coming back over and over again. And I ask myself, is that a reflection of our unconscious bias, or is that something
that's
really
a great
there?
question.
Right.
So we think the world is centered around us, that the world revolves around the earth, until we found out it didn't, But I think we have to be clear that a computer can think faster than our brain. Okay, its clock speed is going to be much faster than us.
Mm-hmm.
But it does not make the connections that we make. It does not have 10,000 connections at once like our brains can. And it doesn't learn the same way that we do. And so there's a very key, fundamental, and I think permanent difference between the way computers and systems that we're developing with AI are going to think and the way that we think. And
So,
that's a
yeah,
whole
go
book
ahead.
probably on its own.
Well, on that note, because we come from the world of operations and automation, we know that when we look at work, there's steady state and transition states. The more you have steady states, the easier the automation problem you
Yeah,
have.
you just optimize that.
Yeah, but it's usually these transition states where the value of the human becomes really important,
Mhm.
right? Whether those are, so you can say that when things go right versus things go wrong, you can have transition states that have been well thought through, startup of a generator or, things like that. But then, disruptions, unplanned for disruptions, those are transition states. And you do need the human, in the loop, in command to do that problem solving. Because a human knows, a human has the ability to go discover new information and look for things and, right?
Well, think about it. Yeah, let's say you have a disruption. Let's
Yeah.
say it is technical and there's something going on, and there is an AI based or an intelligent system that's involved with that very key part of your operation. Is AI going to tell you how you're going to schedule people this afternoon? Probably not. Is it going to tell you how to respond and give the message to the public about what has happened when they're asking, especially if you're, a high-end, very visible company? No, probably not. Is it going to suggest things that you've never tried before? Probably not. It's going to be limited. Even as broad as it's going to get, it's still going to be limited, and it's going to take people. But if the people don't have data, that's the problem. And I think that's the problem we can solve in a concrete way soon rather than later.
Yeah. I think the third thing we discussed was the importance of standards.
Oh, yes.
Yeah, I think the question here is when we go to standardization, you had made reference to black box versus OPC UA. So give me an example of I got to put a piece of equipment out there. I want to pull data from it. I've seen very specialized equipment that's a C# program, and I can't pull any data in from that. So, what are your recommendations to people on standard open standards and what they should specify when going down some of this more data driven approaches and pursuits?
Well, using open networks, obviously, using OPC UA, which to me is a real coup in the sense that it can speak to devices and controllers and also the cloud. It has built-in encryption for security. It's available to the whole world, etc., as opposed to using some field bus or something that's only managed by a handful of vendors or maybe just one. So that should be pretty clear that we're moving to that, where we should be using standards because standards are there to democratize everything. And in the end, if I am a manufacturer, for example, of a device that has to be networked, if I decide, hey, I'm going to force my customers who buy my equipment to use my protocols and my networks, etc., to the exclusion of everybody else, what they're really doing is holding their customer for ransom, and that's not cool. It's not okay. So I think the approach should be using commonly used languages, to do programming. Codesys has been coming along. I think that Linux is in its various forms are also hugely powerful, and the protocols themselves for networking. There's Profinet and Ethernet IP and EtherCAT for devices, and yeah, the whole OPC UA approach, I think, is the direction we should go. The code itself, yeah, I know we have to code, but still the data should be exposed. And that should be the desire from the beginning, is to make all the data exposed and available, but yet at the same time secure and encrypted.
And then the last thing we kind of want to go on is you had talked about this forgotten middle, right? Would you say that standardization is part of the forgotten middle, or is there more to unpack there? And how does this forgotten, let's call it middle, impact your time to value of some of your projects?
Well, I'm finding that they're two different things. It's apples and oranges when you're talking about having open standards and whatnot. I think that's just an approach you could do whether you attack the forgotten middle or not. But the forgotten middle itself is as quickly as we can in a greenfield design ahead of time for pre-made cabling, moving to obviously these communication networks instead of signals, even doing on machine kind of architectures, so we're not running everything back to that cabinet like you mentioned in the steel plant example. Maybe we can do more computing there at site and have hardened systems. If we do that in a greenfield, I think we're way ahead. And then also the time to value on a brownfield will be, okay, let's look at the strategy. What are we trying to get first? What's most important in a kind of a bottleneck fashion? Find the bottleneck, fix it, and then find the next bottleneck. Well, we can do that with this approach too. Where is it that we're having the most effect on our key performance indicators? What are they? Throughput, maybe it's on-time delivery, whatever. If we suss that out, then we start approaching in those places. That's where we're going to get that sight and that feeling and that nervous system in place first. It's not going to happen overnight, but that's the approach. And if you're using open networks, that means that you have a much broader, availability to systems and to people who understand those systems. So it only makes sense to do the standards.
So, given that thought, what advice do you have for OEMs that are trying to enter some of these large juggernauts? So we see connectivity sensors as cost, or they see sensors connectivity as additional cost, but might not see the intrinsic value. So I always see some resistance to one, the open versus their C plus programs, and two, the level of data integrations within your systems. So what is your advice to OEMs out there that are wrangling with, is this extra cost going to bring value, and can I justify it to an end user?
Well, here's what I would suggest, and that's a great question, because if you're building out, you're one of those what I call tier one integrators or line builders, or you have product like conveyor systems or robotics, et cetera. Enter into that conversation with your end customer who's buying these systems and really understand what we've talked about here in this discussion. Help them understand that that's the conversation they need to have to guide their end user to what kind of data are you looking for? How can we make sure we bake that into what we do for you? And that when we're done with this and we're putting this in place, we're handing you the digital twin. Okay, here is the step files for all the 3D and all of the connection diagrams and all the ways that you can get the data out. And let's do more than just provide you the equipment. Let's provide you with whatever that thing does. If it's conveyor, it's the movement of goods. Let's show you how we provide more than just the equipment, but the movement of goods and the data that comes from that. And when you do that as an OEM, you will now put yourself head and shoulders above your competition who's not doing that. And I would even say at the front end of doing these projects, do a digital twin, map it all out. Maybe go in and do a point cloud scan of a brownfield and say, here's our equipment sitting in your plant. We put it in like this, and we're running scenarios with it through some kind of simulation software and saying, this is how we're going to improve your throughput. Now you're consulting on process. You're not consulting on equipment. And I think that's where you raise your game as an OEM or line builder, et cetera, is that you're having that conversation with the key people at your end customer. And that's what's really going to change the game. Then you're not talking price anymore. Price always comes up, but you're really developing a return on investment that's going to be super heavy, super exciting for that end customer to hear. That's the kind of stuff that ends up in the annual report. hey, we invested this $1 billion and we worked with this company for the last 2 years, but now we've gone from 28,000 shipments a day to 48,000 shipments a day, and our customers are delighted, and we feel like we've gained 7 points in our market from our competitors because we did this investment. That's the kind of conversation they should have.
So let's take that just one step further. Let's say I'm ready to do that. I'm ready to step up and provide these services, but I want to do it in a way that is proprietary, and I want to lock you in.
Wait a
Right.
second. All right.
So help us understand the Amazon perspective and the desire for interoperability and not being locked in. The people who, like these companies, the leaders who are changing the game, how do they view proprietary architectures versus open standards and things like that? And how big is, how are they pushing these things?
Yeah, that's a tough one. Very large end users, let's say Procter & Gamble, Amazon, others, will dictate a certain protocol that they're expecting. They already have standards in place. They've had them for years, and that's all very good. Oftentimes, they also want to own the intellectual property of what you're putting into their facility. And those kind of non-disclosure or agreements on intellectual property will vary from place to place. As the OEM or tier one, you're wanting to protect that, of course, protect your property. So you've got to make sure that when you're making those deals, it could be a very big deal, could be $100 million deal, but understand that the end customer is going to have to agree not to share that with anybody else. That's just for their operation, and you might be doing something bespoke for them, in that. But in the end, the locking in part, I don't think that's the right approach at all. To lock in on, okay, moving forward, end customer, you must use us because of the way we've put together our system. I think that's short-sighted. That's my.
So maybe it's not a right versus wrong, but see that there is a healthy tension is important to, let's say, innovation. Right?
Yes, it is. We have to still be able to fund innovation, because if all the power goes to the end user who's saying, I want a delivery system that does this, and you can't have any of your own IP when you do this for me, Mr. OEM, that may not be a good deal. So you have to push back and say, and that's the tension you're talking about as an OEM, saying, we've been doing packaging machines, for example, for 60 years, and we do certain things very specifically, and it is our competitive advantage, and we're never giving that up, and that's that. And eventually the end customer will have to figure out, well, if I want what this system can do, I'm going to have to play by the intellectual property rule that they make. And does it become a black box? It does not have to become a black box. There's plenty of way to put an API where you can push up all the data they want. And what happens in their system, you'll have to warranty, but maybe they can't see everything. And again, that's kind of counterintuitive what I've said. It's a contradiction, but we do still have that information.
And maybe part of this is just shifting the conversation, because I was at a packaging machinery conference a couple of months ago, and there was a company that was one of the keynotes. They were in food and beverage, and the head of packaging equipment for North America, he didn't use the word, the concept of Uber, but that's kind of what he said. Like, I'm in 10 years, I would like to be in a position where I'm not buying equipment from you, I'm leasing, and you're actually more of an information provider. So like I said, he didn't use the word Uber, but that's what they were describing, right?
Yeah, that's a tough one. I mean, you're getting into some philosophy of business too, which is, let's say everything is Uberized. Let's say I have crowdsourced my entire operation through outsourcing, and I am an orchestrator. I'm orchestrating all these, and they all are sort of like agents of mine to do my bidding. And now I want to make a change, and I say, okay, now I want you over here that do this task to do this with this other group over here that does that task, and they have every right to go. No, I don't think so. So your control of your future has been outsourced as well. And I think that's where you're seeing folks like Amazon who are becoming more vertically integrated, building more of their own equipment, doing their own thing because they feel like they want to have that discipline in-house so that they can be agile. And I think the agility piece is probably the biggest answer to that question, which is you got to have that ability to, we've been going east and now we've decided we're going to go north, and that's going to cause all these changes that are going to be painful and expensive for everybody. Who's going to say yes and who's going to say no? Well, if you have the ability to do it yourself, you can just do it.
So, Craig, this has been a great conversation so far. Do you have any final reflections, closing thoughts you want to leave the audience with?
I think that in the topic of AI, and we look at my analogy of the human body, AI is the brain. Okay, it's the thinking and communicating mechanism in IT today, and we're going through a huge revolution. And I'm reading about Stargate project, OpenAI, Oracle, all these folks spending $400 billion, I think, in the US alone to build these data centers. We're seeing the brain advancing very quickly. I'm not seeing the rest of the body and the nervous system following suit. And I think we are dangerously underdesigned in that space. And if we don't design that, we have an uninformed brain floating in space, thinking it understands things. And the simple act of picking something up and understanding what it is and placing it somewhere is a huge physical task. And AI is at its very infancy in understanding the physical world. And in so doing, the sensor companies, the field devices, and our connectivity to them cannot just be, yes, I'm touching it, or no, I'm not touching it. There are almost an infinite combination of things you can feel with your fingers. And so I use that in the book as well, that our systems have to get to that place physically, because we're doing physical things in manufacturing and in e-commerce, et cetera. We're physically moving things in, and I think we're under-designed there. So my point is that if we examine that, there are ways we can do it. And again, we've covered some of those in this talk, the standardization and let's get away from signals and get to data networks, and let's take advantage of this swarm, intelligence that's at the shop floor, so that brain, which is expanding so quickly, can really take advantage of what it is now learning and able to see and able to do for us.
Awesome. Now, where can everybody find your book? I know as of recording today, it's not yet released, but will be by the time this airs. So yes. Where can people learn more about you, find your book?
I would love to communicate with anybody on LinkedIn. You can find me, Craig Henry, also superconnectedbooks.com. Can't go wrong there. That will always be up, and it'll give you links to go purchase. The book is released as of yesterday on Kindle and on Friday this week, and we're recording this in September. So by the time people see this, it will be out. So paperback seems to be the most popular when someone wants something physical in their hand, and that will be available, when this airs, and that's on Amazon, Kindle Direct Publishing. So you just go to Amazon and look up Super Connected, the future of the industrial nervous system, and you'll find it there. I went through a lot of different graphic possibilities for the cover. I'm really happy with the way this turns out. You see all this technology, and you have an Android type robot standing there with its hands up, and you see this human reaching in, and it looks kind of sad almost. There's this touching kind of, they're trying to communicate, they're trying to touch, and they're not quite touching yet. And the point is, we need to be much more involved in this than just trying to reach in and touch it. But anyway, that's where it is. Super Connected Books. Craig Henry. Love to speak with anybody who finds this interesting or wants to chat more. I'm about interconnectivity and also systems that work. I've been doing this a while, so I've seen some stuff, but let's connect.
Awesome. Well, I think it's fitting that given your background, you're making your book available on Amazon. So it only seems natural for you.
Of course.
All right. Well, we're going to wrap it up. Craig, I'd like to thank you again for the insightful conversation. Really enjoyed the conversation. Uncovered some things that, I didn't really take into consideration. Now my brain's churning again. But thank you for spending the time with us.
Yeah.
For sure. And then thanks everybody for tuning into this episode of Practitioners Unplugged. We hope you found these stories and insights as inspiring and as formative as we did. Don't forget to subscribe, leave a review, and give us your thoughts. Let us know where we should take the podcast next. Until next time, keep innovating, keep transforming. Thanks. Bye.